Hello, math humans. Today we are going to do 1.9. We're going to be talking about inverse functions. Our objectives are that we're going to find the inverse of a function, and then we're going to determine if a function is one-to-one. So in previous math courses, you have found inverses. So we're going to go back and review how we do that. So there are three ways to calculate an inverse. So first, let's talk about the notation. If I have f of x is the original function, then the notation for an inverse is f raised to the negative 1 of x. That's going to be the inverse function. And as we think forward, as we move into calculus, oftentimes they will say that g of x is the inverse function. So if you want to use g of x, it makes some of the notation easier, but if you are reporting an answer, you need to make sure that it's clear what your inverse actually is. All right, so the first method is to exchange the domain and the range of a function, which basically means you're going to exchange in the ordered pairs. They're going to go from this to this, right? So this would be the function, and that would be the inverse. So for example, let's say my function has data points 1, 2, 3, 4, 5, and 6. I know that's really creative. When I go to the inverse, those values switch places, and this becomes 2, 1, 4, 3, and 6, 5. This is what your calculator does when it draws the inverse, and I'll show you that when we're just about done. But this is one way of changing the stuff in an inverse. The second method is to kind of do the same thing. So I'm going to switch x and y in, oops, that's an in, the equation, and then I'm going to solve for y. And we'll do an example for this later, but let's say I had y is equal to x squared. Well, if I want to find the inverse, then I would do x is equal to y squared, and then I would have to solve for y. All right, the third method is a graphical method, and that means that I am going to reflect the image of the function over the line y is equal to x. So it makes more sense, I think, if we kind of draw an example. So let's say here's my cute little function, and I have a parabola. And what I want to do is I want to reflect that parabola across the line y is equal to x. And so when I do that, as I come up with all my different colors of pen, this becomes the inverse. So this would be the inverse of the function. Whoop! And then this is the original function. So I take the function and I reflect it across this line. This is kind of a fun thing to do. It's not something that's very practical, but it is another way of calculating the inverse of a function. All right, so while we're here, before we move on to examples, it is important to note that if two functions are inverses, then their composition, so I'm going to say f of x is the function, and then g of x is the inverse, or f negative 1 of x. The cool thing then is two functions are inverses, the composition is equal to x, and it doesn't matter which direction you go. So if I do a composition with the original function and the inverse, both of those compositions will give me x. All right, now let's do an example. All right, so for our first example, we'll start with a nice, polite little equation. So this is example 1. I want to find the inverse, and then I want to verify with the composition. So my first equation, f of x, is going to equal 4x. Sometimes I think it's helpful if you write y is equal to 4x, even though those two things mean the same thing. As I flip-flop the variables, it makes it a little bit easier. So then as I go to my inverse, I'm going to get x is equal to 4y. Remember, the next step, the very important step that we often forget, is that I need to solve for y. So y, which is going to actually be the inverse of the function, is going to be x over 4. And then this would be how I report my answer. For sake of making the math easier, I'm going to call my inverse g of x, because the second part of the problem said that we needed to verify with a composition. So I'm going to do f of g of x. So I'm going to do f of the inverse, which is x over 4. This is now the input into the original function, so I'm going to do 4 times x over 4. The 4's cancel, and it leaves me x. So therefore, we know that f and g are inverses because their composition yields an x. And if you wanted to, you could take the time to do the other composition, but if you've gotten an x on your first try, I would not try the second response, just for the sake of time. All right, so let's move on and do another example that's a little bit more entertaining algebraically. So in our second one, it's going to be the same directions. Find the inverse, and then it's going to be verify with the composition. All right, in this one, my function is going to be f of x is going to equal 5 over x minus 2. So again, just to make my algebra life a little bit easier, I'm going to write it as y equals 5 over. As I get ready to do the inverse, my variables swap places, so x is going to be 5 over y minus 2. Now the goal is to be able to solve for y. This is a little bit tricky. I'm going to cross multiply, but I am not going to distribute. So y minus 2, make sure you use your parentheses, times x is 5. My goal is to solve for y. So y minus 2 is 5 over x. I divided both sides by x. And then y is equal to 5 over x plus 2. Because I have a composition that I'm going to have to do, it's going to make it easier if I put these two together. So I'm going to multiply this fraction by x over x, and so I get y, which is actually the inverse, and I'm going to call it g of x, is going to equal 5 plus 2x over x. So this is my inverse. Now I want to do the composition because the second part said to verify. So I'm going to do f of g of x. So I'm going to do f of 5 plus 2x over x. Now we're going to have some algebra fun. So I have 5, so this is going to equal 5 over, and then I have 5 plus 2x over x minus 2. Again, I'm going to want to be able to put the denominator together as one fraction, so I multiply by x over x. And I'm just going to keep going down. So I have 5 over 5 plus 2x minus 2x over x. Notice that the 2x's cancel. So then this is 5 over 5 over x. Getting better. If I have a fraction divided by a fraction, I'm going to come over here so I have more room. I multiply it by the reciprocal. So this is 5 over 1 times x over 5. The 5's cancel, and look at that. I got an x. So then we can say that f and g are inverses because the composition f of g of x was x. All right, So for our next example, you need to get out your grapher, and I'm just going to show you cool tricks on your calculator. So the first thing that you're going to need to do is you're going to need to put your calculator in radians. So you need to check that your calculator is in radians. We're going to go to our y equals, and we're going to graph y is equal to the sine of x, and I'm going to do a zoom 7, which is a zoom trig, so it goes from a negative 2 pi to a positive 2 pi. It's a very nice window for graphing radians. So your calculator will draw the inverse for you. It won't do anything else. It won't show you that the tables have been flipped and that kind of thing, but it is kind of fun to watch it draw the inverse. So I'm going to do second draw, and I'm going to go down to option number 8, which says draw inverse. I have to tell it what I want it to draw the inverse of, and I want it to draw the inverse of sine, and then I hit enter. So there's the original function. Oh, isn't that cool? And then there is the inverse of sine. So nothing too super fancy, but I thought it would just be really interesting to show you. All right, the last topic I believe that we need to talk about are one-to-one functions. So one-to-one functions. We will use the one-to-one property later in other applications, which is a little bit frustrating, but one-to-one in the application that we're going to talk about now. So let's say I have a function, and it passes both the vertical line test and the horizontal line test, which is the HLT. Okay, so if a function passes both the vertical line test and the horizontal line test, then we say that the function is one-to-one. And what it means the function is one-to-one, that says both the original function and the inverse are actually functions. All right, so let's do an example. In the classic example, well, let's do this one first. So let's do the cubic function. This particular function passes both the vertical line test and the horizontal line test. Okay, so this is my vertical line test. This is the horizontal line test. So this says if I have y is equal to x cubed, the inverse of that function is also a function. Okay, and that's all that tells you. Later it will be more important, but for right now that's going to be the extent of what we do with it. So our last example, example 4, says find the inverse analytically. And we know that that means we're going to have to do some math. Yeah, math. And then I want to know is the function one-to-one. We will use the one-to-one property when we get to logarithms, but that's not for a little while. So our original function is going to be f of x is equal to 2x minus 3. So remember when we start, it's nice if you just rewrite it in terms of y and x. So 2x minus 3, so that when I switch my variables, x is the square root of 2y minus 3. Now I can solve for y. Because y is under a radical, I'm going to square both sides. So I'm going to square this side, and I'm going to square that side. So I get 2y minus 3 is equal to x squared. 2y is x squared plus 3, and then y is x squared plus 3 divided by 2. But remember that I need to report my answer well, so I would say that the inverse of x, or you could say g of x, I would take either, is x squared plus 3 over 2. And I could split that up if I needed to into 1/2 x squared plus 3 halves. Either way is very polite. So then what I'm going to do is I'm going to actually go back to the original function, and I'm going to graph it. And so it has a y, or an x-intercept, sorry, bad math, right there. Then if I look at my function, it passes the vertical line test and the horizontal line test. So then I would say that f is 1 to 1. Then at this point, that's all we want to be able to say is that the function is actually 1 to 1. Alrighty, that's it for today. I will see you soon.